Gauss-Jordan method, except diagonal elements, I want to make rest of the elements 0. To make this element 0, if I consider row 1, what's going to happen? This value is going to change. Construct the augmented matrix in the sense whatever the linear equation I have, I want to represent that in the form of augmented matrix. Each time I am going to get some fractional values because this is known as error. Hello to all, a warm welcome to my new session on solving simultaneous linear equation. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, in my today's session, once again, I'm going to deal with some of the example problem under solving simultaneous linear equation. Before going to start my today's session, let me to recall the topic what I have discussed in my last session. So dear student, in my last session, I started with Gauss-Jordan method. By using Gauss-Jordan method, how can I solve simultaneous linear equation? So dear student, if I consider Gauss-Jordan method, think that I have A, B, C, D, E, F, G, H and I. Okay, I want to consider only the diagonal matrix. Okay, and rest of the elements I just want to make it 0. For example, A, E, I, 0, 0 and 0, 0, 0 and 0. Okay, this kind of solving problem is known as Gauss-Jordan method. In the sense, by using Gauss-Jordan method, except diagonal elements, I'm going to make rest of the elements 0. And I have discussed some of the example problems. Once again, in my today's session, I'm going to solve few more problems under Gauss-Jordan method. Now, let's start the problem, that is apply Gauss-Jordan method to solve the equation. And the given equation is x plus y plus z, which is equal to 9. Then I have 2x minus 3y plus 4z, which is equal to 13. Then I have 3x plus 4y plus 5z, which is equal to 40. Now what I want to do, I just want to construct these linear equation in the form of augmented matrix. So first what I will do, I'm going to write the coefficient of given variables. So x is 1, y is 1, z is 1 and 9. 2 minus 3, 4 and it is 13. 3, 4, 5 and it is 40. So this is my augmented matrix. Now this is my column 1, column 2 and column 3. This is my row 1, row 2 and row 3. Now what I want to do, I want to solve this linear equation by using Gauss-Jordan method, and I want to find the approximate solutions for the given variables x, y and z. So here I have the augmented matrix. For this I'm going to apply the 0. In the Gauss-Jordan method, except diagonal elements, I want to make rest of the elements 0. So here I want to make this element 0 at the beginning. So for that what I will do, I'm going to consider the first row. Okay, so when I multiply 2 by first row, I'll get the answer 2. 2 minus 2, it is 0. So R2 minus 2R1. So I just want to make this element 0. And I'm going to apply this formula to entire second row. Now I want to make this element 0. Now I want to apply the formula for entire row 3. So here 3R1 minus R3. So I'm going to get the answer 0. So dear student, I'm going to apply this formula to entire row 2 and row 3, and my first row remains as it is. So dear student, after applying the formula, I got 0, minus 5, 2 and minus 5. That is my row 2. Now 0, 1, 2, 13. This is my row 3. Okay, if I consider row 2 and row 3. See here I have minus 5 and here I have 1. It is difficult to construct the formula. So what I'm going to do, I'm just going to interchange row 2 and row 3. So after interchanging, see here, I'll get the matrix, that is 0, 1, 2, 13 and 0, minus 5, 2, minus 5. So what I did here, I just interchanged row 2 and row 3. Now what I want to do, I just want to make this element 0. To make that element 0, what I will do, okay, I'm going to consider row 2 and row 3. Suppose if I consider row 1, what's going to happen? After substituting the formula, this value get changed, but I don't want to change 0. Okay, now what I'm going to do, I'm going to consider row 2 and row 3. So what is the formula? I'm going to have R3. So I'm going to change in my row 3. So it is R3. R3 plus 5R2. Okay, now when I substitute R3 0 plus 0, I'll get 0. Then minus 5 plus 5, it is 0. Then I will get 2 plus 5 into 2, 10, which is 12. Then I'll get minus 5 plus 65. So what is the answer I'm going to get? That is 0, 0, 12 and 60. Now see here, if I consider lower triangle here, all the values are 0. Now what I want to do, I just want to make only these 3 elements 0, except diagonal matrix. That is, except diagonal elements, I just want to make rest of the elements 0. So dear student, I'm going to make this element or this element 0. So here first I will make this element 0. To make this element 0, I just want to consider this element. So I'm going to prepare the formula, that is R1 equal to R1 minus R2. Okay, so what I will do, I'll write second row and third row as it is, and I'm going to change only the first row. So what is R1? 1 minus 0, so it is 0. Now 1 minus 1, it is 0. Next time I have 1 minus 2, so I'll get minus 1. So I got minus 1, see here. Next I have, what is R1? That is 9 minus 13. So I'm going to get the answer minus 4. So I got the answer minus 4. Okay, see here. I'm going to simplify these two values. See here. I have 12 and 60. Okay. And if I consider these values, it is very difficult to prepare the formula. So what I will do, I'm going to divide this row by 12. So 12 ones are 12 and 12 fives are 60. See here, 12 ones are 12 and 12 fives are 60, and rest of the rows as it is. Now see here, I want to make this element 0. So what I'm going to do, to make this element 0, I'm going to consider row 3. Suppose to make this element 0, if I consider row 1, what's going to happen? This value is going to change. But I don't want to change the value 0. So what I'm going to do? I'm going to consider the third row. Okay, fine. Now see here, when I multiply this by 2, okay, I'll get 2. 2 minus 2, which is 0. So what is the formula? R2 equal to R2 minus 2 R3. Now I will write row, that is first row as it is and third row as it is. Now see here, 2 0 minus 2 0, which is 0. Now 1, that is R2 is 1 minus 2R1, that is minus 1. So I'll get the answer 1. Fine. Then see here, R2 is how much? It is 2 minus 2, so which is 0. So I'll get the answer 0. Now R2 is 13 minus 10. So the answer is how much? The answer is 3. Fine. Now I just want to make this element 0. And if I consider this one, all are identical matrix. So I have 1 in all the place. Okay, now to make this element 0, suppose if I consider R2, what's going to happen? The R2 row value is going to change. But I don't want to change R2 row values. So what I will do, I'm going to consider R3. So here I have minus 1 and here I have plus 1. So minus 1 plus 1, it is 0. So here I will write the formula R1 equal to R1 plus R3. So what is R1? It is 1, and what about R3? 0. So I'll get the answer 1. So I have written 1. Now R1 0 and R3 is also 0. So I'll get the answer 0. Next time R1 is minus 1. Then R3 is plus 1. So I'll get the answer 0. So it is 0. Now what is R1? It is minus 4. Then what about R3? That is 5. Okay. So minus 5 plus 1, that is 1. Now dear student, this is my final answer. Because see here, all are identical matrix and I have 1, 3 and 5. So x equal to how much? 1, y equal to 3 and z equal to how much? It is 5. So z equal to 5. So dear student, this is the final augmented matrix and all the elements are identical, and this is the example for identical matrix. Now what I want to do, I want to find the x value, y value and z value. So to find the x value, what I have? X equal to 1, then y equal to, I have 3 and z equal to, it is 5. Now if I consider any equation from the given question, okay, see, I'll take this one, x plus y plus z equal to 9. And if I substitute the value, I have to get 9. So x plus y plus z, which is equal to 9. So 1 plus 3 plus 5, which is equal to 9. So 9 equal to 9. This is the way I can cross verify. So here RHS equal to LHS. Now dear student, I have another problem under this method, that is x plus 2y plus z equal to 3 and 2x plus 3y plus 3z, which is equal to 0. 3x minus y plus 2z, which is equal to 13. So what I want to do? First I want to construct the augmented matrix, in the sense whatever the linear equation I have, I want to represent that in the form of augmented matrix. So I'll write the coefficient. 1, 2, 1, 3. 2, 3, 3. So 3 minus 1 and 2. And it is 13. Now see here. I want to make this element 0, this one 0, this one 0, this one 0, this one 0, and this one 0. Except these values. Rest of the values I want to make it 0. So what I will do, I'm going to write the formula. That is R2 equal to, see here, if I consider this R1 and if I multiply R1 by 2, I'll get 2. So 2 minus 2, it is 0. And here it is 3. So if I multiply R1 by 3, it is 3. 3 minus 3, it is 0. So I'll construct the formula R2 equal to R2 minus 2R1 and R3 equal to R3 minus 3R1. Okay, so after substituting the formula, see here, I'm not going to change row 1. So what I will do, I'll write row 1 as it is and I'm going to change row 2 and row 3. So after substituting the formula, I'll get 0, minus 1, 1, 4, 3, minus 7, minus 1 and 4. So dear students, see here, R3 equal to minus R3 minus 7 R1, because see here, I want to make this element 0. So what I want to do, I just want to make this element 0. So to make that element 0, what is the formula? See here, I am going to consider the row 2. So minus R3, and when I multiply this one with 7, so I'll get minus 7 plus 7. So both will get cancelled. So I'll get the answer 0. So dear students, see here, after applying the formula, see I'm going to apply only for the row 3. So 1, 2, 1, then it is 3, 0, minus 1, 1, 4. See here, 0 minus 1, 1, 4. So 0 minus 1, 1, 4. Then 0, 0 minus 8 minus 25. So dear students, see here, okay, if I consider this matrix, all the lower triangle matrices are 0 and only the upper triangles are remaining. Now I just want to make these three values 0. So what I will do now, what is R2? R2 is 0 minus R1, it is 1, so I'll get minus 1. So I got minus 1. Now R2 is minus 1, then minus 2, it is minus 3. Now see here, 1 minus 1, it is 0. Then I have 4 minus 3, which is 1. So I want to get the answer minus 1 minus 3, 0 and 1. So I got minus 1 minus 3, 0 and 1. And I'm going to write rest of the element as it is. Now dear students, see here, okay, I want to make this element 0. To make that element 0, what I will do, I'm going to consider second row. Okay, so R1 equal to row 2, and when I multiply this one with the value 3, 3 3s are how much? It is 24. Okay, 24 minus 24, I'll get the answer 0. So here 3R2. So it is R2 is how much? 0 minus 8. Okay, 0 minus of minus, it is plus, so I'll get the answer 8. Now 24 minus 24, it is 0. Now once again it is 0. Then I have 3 into 7, 3 into 7, 21 minus, okay, 1 into 8, it is 8. So answer is 13. Now dear students, see here, I got all 8 minus 8 and 8. Fine. Now 8x equal to 13 minus 8y equal to 7 and minus 8z, which is equal to minus 25. So dear student, x equal to 13 by 8. So I'll get some fractional value which is nearer to 2. So I'll write 2. And if I consider y equal to 1, because y equal to 7 by 8. Okay, when I divide, I'll get some fractional values which is nearer to 1. So I will get the answer -1. Now, dear student, if I consider z equal to 25 divided by 8, so I'll get some fractional values which is nearer to 3. So I'm going to consider 3. So dear students, see here, each time I'm going to get some fractional values because this is known as error. Okay, so this is known as error because if I make any small modification in my given number, okay, I'm going to lead some fractional values. Okay, this is known as errors. Okay, this is known as what? Errors. And I'm going to get some fractional values. Even though if I get the fractional values and if I make the round figure and whatever the round figure I'm going to get, and even if I substitute these values in the given equation, once again I'm going to get same answer. So dear student, see here, I have x plus 2y plus z which is equal to 3. Thus, x plus 2y plus z which is equal to 3. So, what is x? 2. And what is y? -2. And z is 3. And it is 3. And if I consider RHS as well as LHS, see, I'm going to get the answer 3 and 3. Even though if we get fractional values and if we round up with the values, then also we are going to get the exact answer. So this is the way I can able to cross verify. And if we get fractional values, then it is treated as error. So dear student, if we make any modification in the given linear equation, then it leads to error in the final solution. So dear student, these are the some examples for Gauss-Jordan method. Anyway, dear student, let's meet in the next session with the new concept, that is Lagrange's interpolation formula. Until that, keep watching and keep learning. Thank you.